Radioactive isotopes decay and send out radioactive emissions.
These can be detected using a Geiger Miller tube, which can be linked up to a scaler, a rate meter, or an amplifier and loudspeaker.
Scientists need to be able to measure the level of radioactivity in an isotope, but this presents a problem.
The problem is that the amount is constantly decaying. In any given sample, atoms may have been decaying for days, months, years, millennia, or longer. You cannot simply count something that has happened when it no longer exists after it has happened.
This is why physicists use the term half-life when describing the level of radioactive decay in radioactive isotopes.
The half-life of a radioactive isotope is the time taken for half of the nuclei in any given sample to decay. We can use a Geiger Miller tube linked up to a rate meter to calculate the number of nuclei that decay per unit time, and then calculate how long it takes for the rate to halve.
This will give us the half-life. As an example, iodine-131 has a half-life of 8 days. This means that for any given sample, the rate of decay halves every 8 days, regardless of how many atoms there are in the sample. Half of them will have decayed in the first 8 days. Over the next 8 days, half of what was left will have decayed, and over the next 8 days, half of what was left again, and so on. The shorter the half-life, the more radioactive the substance is, because it will be emitting radioactive emissions very quickly.
The half-life can be seen in two ways. It is the time taken for a 50% drop in the rate of radioactive emissions. It is also the time taken for the amount of radioactive materials to fall to half its previous amount. This is Science Rocks.